Well, hello everyone. Again, this is Mr. Reeves back with you, and we're going to be looking at finding the area of composite figures. So I hope if you have been having some difficulty finding the area of polygons, you took the time to watch my videos that I made. I used these formulas right here, and I showed you how to find the area of those quadrilaterals as well as triangles. So excuse me, if you did not get a chance to watch those videos, you might want to go back and do that, because if you can't find the area of these polygons, then finding the area of composite figures is not going to be a possibility. All right, so let's go ahead and take a look at some examples here. So I'm in the textbook on page 279 if you wanted to work through these in your textbook with me. All right, so we're asked to find the area, and just a reminder, finding the area is finding the number of squares that fit inside that shape. And the size of those squares depends on the unit. So since this area is measured in feet, I want to know how many square feet. I'm going to go ahead and put that right there. I'm looking for how many square feet will fit in that figure. On this one, because the units are meters, I'm looking for how many square meters will fit in this figure. Now, these are called composite figures. Composite means you're putting different things together. It's made up of different parts. So what we have to do is, instead of finding all the area at once, we're going to find the area of different parts. So if you take a look here, this figure, I'm going to put a 1 here, I'm going to put a 2 here, and I'm going to put a 3 here. So 1 and 3 are triangles, and 2 is a rectangle. So I'm going to find the area of 1, then I'm going to find the area of 2, and then I'm going to find the area of 3, and when all is said and done, I'm going to add all those together, and when I'm done, that will give me the total area. Okay, I hope that makes sense to you. All right, well, what shape, what polygon is area 1? Well, that's a triangle, right? Area 2 is a rectangle, and area 3 is a triangle. So that's why I was saying you need to know how to find the area. You need to know those formulas. Well, the area of a triangle is 1/2 the base times the height. And the area of a rectangle is the length times the width. And the area of a triangle, once again, is 1/2 the base times the height. All right, I wish I would have made these just a little bit bigger. All right, so what do we have here? We have a triangle. In fact, these are right triangles. And in a right triangle, the great thing is, except for this length, which we call the hypotenuse, these legs, one is the length and one is the width, or rather, one is the base and one is the height. If we made this into a rectangle, then those would be the length and the width. So the area of that triangle is going to be 1/2 times 2 times 3. All right, so ladies and gentlemen, 2 times 3 is 6, and 1/2 of 6 is 3, right? So the area for this first triangle is 3, and the units would be 3 square feet. So 3 square feet is the area of that triangle right there. What about this triangle right here? Well, that one, the length, I'm sorry, I did it again. The base and the height are both 3. Oh, actually, that was doing the triangle down here. My bad. All right, here we go. 1/2 of 3 times 3, right? The base and the height are both 3. So I get 1/2 of 9. And please don't tell me you can't take 1/2 of 9, because 9's an odd number. It has a half. It just will have a half when you take a half. And you get 4.5 square feet. So the area of this triangle is 4.5 square feet. Let me circle that like I circled the other one. All right, here we go. And then finally, the rectangle, which I called number 2, area number 2, the area of a rectangle is length times width. All right, now we have to be careful here because you see this 8 and you might be tempted to use 8 for the length, excuse me. But if you take a look, 1, 2, 3, 4, 5, 6, 7, 8, they did make these to scale. 8 is only this part right here, right? That part right there is 8. What else do we have to include for this rectangle? We have to include that 3 right there, right? So the length of the rectangle is not 8. The length is 8 plus 3, or what? 11 feet. All right, the height is in fact this length here, which is 4. So we need to do 11 times 4, and we get 44 square feet. So the area of this rectangle is 44 square feet. All right, but we are looking for the area of the composite figure, which is all of those things put together, right? We're going to add those together. What are we adding together? We're adding the area of the top triangle, which was 3, the area of the bottom triangle, which was 4.5, to the area of the rectangle, which was 44. This is taking way too long to color this. All right, but you get the idea. We're putting those areas together. All right, and 3 plus 44 is 47, and 47 plus 4 is 51.5. By the way, you can add in any order you want to. 3 plus 4.5 would have been 7.5. 7.5 plus 44 would have been 51.5, not 51.1. Just making all kinds of mistakes today. All right, 51.5, right? Or we could have added these together and gotten 48.5 plus 3 and gotten 51.5. So the area of that composite figure is 51.5 square feet. 51.5 square feet. All right. So 2 triangles added to a rectangle. All right, what about this one? So when you're finding the area of composite figures, sometimes it's not super clear how to break it up. This one's pretty clear. What do we have right here? Right here, I'm going to call this figure 1. Figure 1 is a square, and what do we have here? Figure 2 is half of a circle, right? So if I were able to, okay, let's see if I can pull this off. I don't know. All right, I'm going to try to make a circle here. Actually, I know what I'll do. I'll use my handy-dandy compass, and then I definitely will be able to pull it off. So if I go here, and I set my compass, that's my radius, and I go all the way around. All right, I'm slightly off, but that's really not that bad. All right, you could see that makes a whole circle, correct? But I only have how much of it? I only have half of it. So this part right here, that figure number 2, is half of a circle, right? So I'm going to take this circle here, if I can grab this circle, and I'm going to delete that circle. Well, I'm going to try to delete that circle. How about this? How about if I drag it into the trash can? There it goes. Okay, much better. So we have this half of a circle, right? And then right here we have a square. So figure 1, so area 1 is a square. And the area of a square is the side squared, right? Again, if you didn't watch that video or you haven't practiced that, make sure you practice area polygons before you try to do this, all right? So what is our side? Our side is 10, so the area is 10 squared, or 100. And by the way, it's 100 what? This one's not feet, this one is meters squared. So the area of that one is 100 meters squared right there. All right. Well, what about the area of this one? So area number 2 is called a semi. Actually, let me just do this. I'm going to put half circle. It is officially called a semicircle. I'm going to call it a half circle. All right. So the area of a circle is pi times the radius squared. I hope you remember that. The area of a circle is pi times the radius squared. So a half of a circle is going to be pi times the radius squared divided by 2. Or if you prefer, 1/2 times pi times the radius squared. And if you notice, they told us right here to use 3.14 for pi. Make sure you're paying attention to those instructions because otherwise it might cost you some points when you take a test or a quiz. All right, so here we go. So we're going to do pi times the radius squared. Now wait, what's the radius? Well, the radius is the distance from the center to a point on the circle. So that right there is my radius. Let's see, 1, 2, 3, 4, 5. Am I doing that right? I'm going to count this way just to make sure. 1, 2, 3, 4, 5. Well, of course it's 5, Mr. Reeves, because all the way up and down, that would be the diameter, right? All the way up and down would be the diameter, and the diameter is 10, so the radius is 5. So r is 5. So it's pi times 5 squared, but then we're going to have to take that answer and we're going to have to divide it by 2. Divide it by 2. Or if we wanted to, we can multiply a half first times the pi times the 5 squared. All right? Okay, so for this one, I think I'm going to go to my handy-dandy calculator, which I haven't opened up yet. That's a mistake. Sorry, we're going to have to watch our calculator open. While we're doing that, hopefully you guys know what 5 squared is, right? 5 squared is 25. So we're actually going to be doing pi times 25 divided by 2. There's my handy-dandy calculator. And I'm going to go ahead and turn off the key history there. And I'm going to clear all this out. And here we go. So I'm going to put in my calculator. Now, normally we put the number before the pi. It really doesn't matter. Pi is a number as well. But I'm going to go ahead and go 25 times. Now you have this pi button on your calculator and you might be tempted to use it, and to be honest, that would actually make your answer more accurate. But they've asked us to use 3.14 for pi, so we're going to go pi times 3.14, and then I'm going to put enter. So if this were an entire circle right here, the area would be 78.5, but I only want half of that, so I'm going to divide that by 2, and when I do that, I get 39. What was it? 39.85? Come on back. 39.25. All right, 39.25. 39.25 what? Again, what are the units? The units are meters squared. All right, so the area of this part, this half circle or this semicircle, is 39.25 squared. So again, what do I want? I want the area not just of this, but I'm going to go ahead and add in, you know what, I learned my lesson. I'm going to make this big ol'. There we go. It'll go a lot faster now when I color it in, right? Okay, so I'm now adding in this area of the square right here. And what was the area of this part? The area of this part was 100, right? And the area of that is 39.25. And I hope you don't need a calculator to add those two together. You get 139.25 meters squared. All right. Okay, so there's the area of 2 composite figures. Again, this one was 2 triangles added to a rectangle. This one was a square added to half of a circle. All right, let's go see if we can find another example where we can work out. Wow, how about this one right here? Well, there's no units on that one, so I want to do one where we have units. How about we do this one right here? Number 8. I'm going to do number 8 on page 281 in your textbook. Number 8 on page 281. So here we go. Let's take a look at these shapes. So I hope you can see pretty quickly that this divides into 3 regions, right? Region 1 or area 1, area 2, and area 3. So here we go. We got area 1. Then we're going to have over here, I'm going to do area 2. And then below that, I'm going to do area 3. And then when all is said and done, of course, I'm going to add those 3 areas together, and I will have the area of the entire composite figure. Okay, so let me ask you, what do we have here? 1. You know what? I'm going to hold off on 1 for a minute. I probably shouldn't have made that one the first one, but I did. All right, let's do 2 first, because 2, I hope you can pretty quickly see what 2 is. Take a look. What do we have on number 2? We have a square, correct? Do you see that square right there? There's our square. So for area 2, we have a square, and the area of a square, again, is the side times itself. So the area is going to be 8 times 8, or 64, right? And again, the units are meters. So when we find the area, it's always in square units. So the area of the square is 64 square units. That takes care of that part right there. All right. Area 3. What is area 3? Area 3 is a triangle, and not just any triangle, it's a right triangle, right? And this distance here is 8. That's going to be our base. What's this distance right here? Well, it's going to be the same as that one. That is also 8, right? So the area of the triangle, do you remember what the formula is? 1/2 base times height, right? 1/2 base times height. So it's going to be 1/2 of 8 times 8. Now, as you guys know, if you've been paying attention, you could do half of 8, which is 4. 4 times 8 is 32. Or you could do 8 times 8 is 64, and 64 times 1/2 is 32. Either way, we get 32, and once again, it's meters times meters, so it is 32 square meters. So that is the area of, that right there. All right. So we have the area of the square, right? We have the area of this triangle. We just added on the area of this triangle. Now, what about this? Now, this one may throw you off a little bit, because if you go, oh, well, if it were like that, it would be a triangle, right? But it's kind of like a triangle with a curvy side. All right, well, what is that? Well, I'm going to get out my compass again, and I'm going to go right here, and I'm going to go here. And maybe, let's see how we do this time. Do we do any better? Oh, not too bad. So do you see right there we have a circle? Do you see that circle? And what do we have here? But we have 1/4 of that circle, right? We have 1/4 of that circle. So I can draw that part there and that part there straight. But this part right here is curved. So I can't use the straight line. I have to try to do this on my own here. Whoops, why do I have a line if I can't do it with a straight line? Here we go. Let me try this again. So that right there, oh my goodness, all kinds of swirlies. That right there is, when I put all that together, I get 1/4 of a circle. Do you see the 4 parts of the circle? 1, 2, 3, 4 going around, right? Okay, so I have 1/4 of a circle. So again, I'm going to get this circle out of the way here. So we have 1/4 of a circle. So I'm going to go right here, and area 1 is going to be 1/4 of what? Pi times radius squared. Or another way to say that is pi times the radius squared divided by 4. I think sometimes students do a little better with dividing by 4 than multiplying by 1/4, even though those are the same process here. Okay, so now we have to figure out what is that radius. Well, that radius, again, is the distance from there to there, right? Which they didn't tell us that, did they? But that is also the same as from there to there. And that one we know because this is a square. So the radius of this circle is 8. We're seeing a lot of 8s in this problem, aren't we? 8 was the side of the square. 8 was both sides of this isosceles right triangle. And 8 is the radius of this fourth of a circle. All right, so here we go. So I'm going to go with this one right here. So I'm going to go pi times 8 squared, and then when all is said and done, I'm going to divide by 4. Pi times 8 squared divided by 4. So if we were following this in order of operations, if you weren't using the calculator, you'd make sure you do 8 squared times pi and then divide by 4. All right, in fact, that's how we're going to put it into the calculator. Pi times the radius squared. Then we're going to take that answer and we're going to divide it by 4. And that will give us the area of 1/4 of a circle with a radius of 8. So let's pull that calculator back up, clear it all out. And again, I'm going to start with the radius squared. 8 squared. There's my squared button. 8 times 8. And then I'm going to multiply it by. Now again, I might be tempted to push that pi button. But what do they say right here? Use 3.14 for pi. So I'm going to use 3.14 for pi. So that's pi times, or what we're putting in for pi, times the radius squared. Right? And then we're going to take that. That would give us the whole circle, right? That's the area of the whole circle, but we only want 1/4 of it. So we are going to divide that by 4. And when all is said and done, we get 50.24. 50.24. And again, the units are meters squared. All right, so that is the area of that right there. Okay? So again, what do we want to do? We want to add all those areas together, right? So we actually, let's work our way backwards. We just finished with this part right here. We just finished with that part. That is area of 50.24. We started off by doing the square, which is right here, correct? And then we did this one here, and we're going to put all those areas together. And when all has been done, we'll have the area of that composite figure. All right, so I'm going to go to my calculator this time, and I'm going to add all those together. So I actually have 50.24 already in there. So when you're using your calculator, if you have one of these TI calculators, if your answer is already there, you can just, like I knew I wanted to add to that, so that ANS says to take what you have and add, just like this one right here. We took the answer and divided by 4. I didn't have to retype it in. So this ANS is actually 50.24. And then I'm going to go ahead and add 64 to that. And then I'm going to add 32 to that. And what do I get? I get 146.24. 146.24. Goodness gracious, Mr. Reeves, let's try this again. 146.24. And 146.24, what? What are the units? They are meters squared. All right, so that is the area of that composite figure. So that's 3 examples. I hope you can see how this is done. On this one right here, we would add the area of this rectangle to the area of this circle. Again, I just do want to warn you, sometimes you're going to be working with parts, right? So you're going to have to add together. So if we were doing this problem right here, this length and that length are the same, right? So if we were looking to find the area of that triangle, it would not be 3 times 6. It would be 7 times 6. The height would be 7. Of course, because it's a triangle, we would have to divide that by 2, and then add that to the area of the rectangle. All right, this one right here, we would find the area of this rectangle and add it to the area of this triangle. Do we have any more we could look at? Ooh, this one right here. Wow, so this one right here, we'd have to draw some lines in, and we could do it differently. I can go across like that, and if I went across like that, I'd have the area of a trapezoid plus the area of a rectangle. People sometimes struggle with finding the area of trapezoids, so maybe you want to do this instead. Maybe you want to, sorry, that's kind of crooked. But right here, what do I have? I have a rectangle. It might even be a square if I look closely. And then two triangles added together. So you actually have a choice many times on how you break it up, right? This one here, I have this square. I believe it's a square plus these two triangles. Or if I wanted to, I could go straight across like this, right? And then I have a trapezoid on top of a trapezoid that I could do it that way if I wanted to. All right. This one right here, ooh, this one's going to involve subtraction. This is kind of cool, actually. This one right here, what I'd want to do is find the area of the entire rectangle, right? And then what am I going to do? Then if I do the area of the entire rectangle, right, then what have I done? I've included those white parts, but those white parts aren't supposed to be included, right? So what do you have to do then? You have to, ooh, messed up. You have to then go back and take those away, right? So this one is going to be the area of the rectangle minus two half circles. But what do you get when you put two half circles together? You get one circle, right? So in order to do, if you guys were working on number 14, it's going to be the area of the rectangle minus the area of the circle, okay? But I'm going to let you guys work on those on your own. Of course, if you get stuck, you're welcome to ask for help. All right, I hope this video helped. Have a great day, everybody.